Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 248 on Leetcode, longest common subpath. So hit the like button, hit the subscribe button, join me on Discord about this problem, other contest forums, let me know. We actually usually go over, in chat, in Discord right after the contest. So if you're a contest nerd like I am, or maybe you just like it, come hang out. Anyway, today's problem is today's Q4 is longest common subpath. So this one is a hard problem. Obviously, I spent an hour and 10 minutes on this, and not many people solved it, right? About 122 people, maybe a little bit more now. I think the count is a little bit off, but you get the idea. Not many people solve it. So there are a couple of dots that I thought during the contest, and you could watch me solve it live, though obviously fast forward afterwards because it's a long time. I actually tried doing some stuff with keeping track of pointers, or I even tried doing a breadth first search thing where, okay, I start with the path of length 1, keep track of everything, try length of path of length 2, and so forth, but that was too slow. I tried doing that, but with almost like an A-star search, if you want to call it that, where it built from furthest first, but it was still too slow. And you can actually see some of the techniques that I did to kind of test a long test case. Something that I wouldn't say I discovered it lately, but something that I personally came up with lately of creating long TLE test cases, so you can look into that later. Maybe I'll even go over it during the content or during the problem explanation as well. So those are the things I did. The other thing that I would mention is that to me, to be honest, this was a very obvious suffix tree, suffix array problem. If those things don't mean anything to you, probably don't worry about it. If it's something that you're curious about, definitely read about it. It's actually very interesting, very nerdy. I loved it, but it's also something that, to be honest, I have never implemented it in my life optimally. I implemented a sort of a suffix array in another language previously, but not optimally. So, but that said, if that's something that you're interested in, then play around with that. But that, just to be clear, that, like I said, I've almost never done in my life. It is ridiculously hard. Though someone did it, I think, in the experts, like if you look for the other people's solutions. So that people have done it because people have pre-written libraries, and I didn't have a pre-written library. I'm not going to Google someone else's library or something like that. So I didn't do it that way. And to be honest, if you watch me solve the contest, I spent about an hour, maybe an hour, give or take, on the wrong solution. And then, to be honest, at the very end, I did something a little bit YOLO-y, because I thought for an hour that it was the wrong solution, that it was going to be too slow. But I have to do something tighter about the math, because I think the thing is that the key part of the constraint is that the sum of the path is 10 to the 5th. So there is some math here that makes it, I cannot prove a tight bound on this one, or at least maybe my math is just bad. So if you know how to do the proof, leave it in the comments below. So yeah, so basically what I did is binary search. So I did a binary search on the answer. And what does that mean? That means that, okay, I asked myself, is there an answer of length x, right? If there's an answer of length x, then let's try an answer of length of a longer length, right? If there's no answer of length x, let's try a smaller length. That's basically the idea. And if you kind of say it that way, my computer's a little slow, sorry. If you say it in that way, then you can see that if there's an answer of length x, then every length of x plus 1 has to be true, right? Because if, for example, if there's a path of length 5, oh, sorry, wait, I said that the other way around, huh? Sorry, I really mixed it up. Okay, I meant the other way around. Wow, that is really bad, actually. Sorry about that. I hope I didn't confuse you. But basically, if there's a path of length 5, that means there's always a path of length 4, and there's always a path of length 3, and so forth. right? And if there's no path of length 10, say, then there's no path of length 11 and or 12 or 13, right? Because you can construct that from the paths directly. Because if there's a path of length 5, then obviously in that path of length 5, it contains the path of length 4. So basically what that means is that if you look at all possible answers, it's going to look like something like this, where, okay, there's a path of length x, there's a path of length x plus 1, until some other number, and then it's not going to contain that number. So t means true, f means false. It means that, okay, at certain point, x is not going to have a path of length x, and then there's no path of x length minus 1, and so forth. So then the idea here is, okay, there are only two possibilities, of course, which means that, okay, if we test an x and it's true, what does this mean, right? That means that this, well, first of all, it means that if this arrow is mid, then first of all, it means that mid is true, right? Or mid is a possible answer. And then we want to get rid of everything to the left because we know that we don't care about it anymore, because we know that if nothing else, mid is the answer, right? So, okay. Yeah. So that goes to my binary search, which is that, if mid is good, then we set left is equal to mid, because in here we have an inclusive range of left, right. So when left is equal to right, then our range is contains one number, right? So that's basically to me explaining binary search a little bit. So that explains this while loop. If this is good, then that means that we can set the left side to mid, because left is inclusive, or this is an inclusive range, and mid is a possible answer. If not, we know that right is not a possible answer, and we set to mid minus 1. And going back to here, if this is a false, that means that this is not a right answer, and also everything to the right of it is not a right answer, and that's why we have a mid minus 1. And therefore, mid, I do it add 1, because so that you can think about it as rounding up, because this makes it round down for whatever reason. So that's the binary search portion. Yeah, take some time to kind of understand that part, because the next part is probably the harder part. Yeah, and then the next part is what there are a couple of ways to do this. I think there's you can use Robin Cobb, you could use KMP, but I use Robin Cobb to kind of do fingerprints. Oh yeah, let's actually go over this a little bit as well. So here I chose so the smallest possible answer is 0. The biggest possible answer is the length of the smallest path, because you cannot have the shortest path. You cannot have a longer common path than the shortest path. And keeping in mind that here that I sort the path by its length in the beginning. Right? I know that I'm jumping a lot. Sorry about that. But yeah, I sort the paths by the shortest path, or by the path lengths, and then I take the inclusive path to be the length of the shortest path. Okay. And then now going back to the good function. So I use Robin Cobb, and basically what I do here is that, okay, here, generate fingerprints for paths of length target. And I'm not going to go over Robin Cobb that deeply in this video, because it's an interesting algorithm and it's a good algorithm. I definitely recommend you go over it, but yeah, it's going to be a really long video if I go over that. So, but basically the idea is that I generate fingerprints for path of each length target, and this is basically the way to do it. You can think about it as actually what we did earlier with modpow. You just basically keep a rolling. You hash the substring, and then you kind of shift it over by 1, and then you hash that, and so forth. If you do it naively, it's going to be really slow, but the part about Robin Cobb is that you can kind of think about it as shifting it 1 digit at a time, and then chopping it also 1 digit at a time. And that's basically it. And this is kind of like sliding window as well, and then I keep track of all the fingerprints in the hash set. And then now, for every other path, I go over it as I generate fingerprints as well, also for length target. And yeah, as soon as this is found, we're done, because we know that it is good for this path. Otherwise, if it is not found, then we return false, because that means that not every path has to contain the same thing. And basically, the reason why I did this fingerprint is so that we can match in all of one time, which is this lookup thing. If current is an S, for every fingerprint, we're able to match all possible paths of length target in all of one time. So basically, S now contains all possible paths of length target. And this allows us to look up all possible paths of length target in O of 1. So that's basically the idea. Yeah. And in this case, I guess now I could explain this a little bit better in terms of paths. So this algorithm, and you could kind of do your math yourself, but this is going to be O of 1, maybe expensive O of 1, but each loop is going to be O of 1, and this is also going to be O of 1, right? Or O of 1 per character, sorry. And of course, so that means that this actually takes O of M times, or not M, it's this M, sum of, so this is going to take O of sum of path of length times, which is less than 10 to the 5th, because as you can see, for each character, we do O of 1 operations. That's basically the short reason why. And because we call this as part of the binary search, as we said, this is going to be at most log M, roughly speaking. So right is M, which is less than 10 to the 5th. And because of this, oh, sorry, whoops, did I miss this? Oh yeah, the right is the thing. So the binary search will be O of log M, or, you know, yeah. And of course, this good function, as we said, is going to be O of sum of paths. So this is roughly 10 to the 5th. Oops. Just to be clear, because it's sum of the paths, right? It's not just M, because each M could be 10 to the 5th, but you can only have one of them or something like that, right? So that means that this is going to be, total time will be O of M log M. So that's basically the idea. In terms of space, it's also O of, depending on how you want to count it, it's either O of M space or O of log M space, mostly dominated by this set thing, because we have to create it for every binary search. But if you want to say, oh, we free the memory and then it becomes O of M bound every time, and we reuse memory, then, you know, instead of creating a new one, then it's O of M space, but space is O of M or O of M log M, depending on how you want to count it. But, you know, that's basically the idea. Cool. That's all I have for this one. I'm going to make this a little bit smaller so you could see more of it. At least you could see this good function, the binary search. You can also look at it in a second. Yeah, you could watch me solve it live during the contest next. So here's the good function, and here's the binary search. Oh yeah, one more thing is that, not gonna lie, I googled a large prime. And this is just a random, I guess this could have been what, this maybe could have been a prime, but it doesn't really matter, right? Well, it didn't matter because I didn't fail, but if it failed, then maybe it matters. But yeah, that's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. You can watch me solve it live during the contest next. Again, it's really long. You could kind of skip through it. I did the binary search stuff near the end, obviously. So, because if it was earlier, then I would have gotten AC earlier. Yeah, let me know what you think, and I will talk to you later. Bye-bye. Knew how to do them, just dumb about it. And this one has... How far back am I? Because no one's gotten this yet, so that's actually Surprising. Alex gotten 3 palms and okay, one person got it. Alex gotten. I am very sloppy today. This is gonna be a mess. Okay. 3 wrong answers. Come on, Larry. N is the number of cities. How many paths are there? There are a lot of paths. Some of the paths, okay. What does this remind me of? Really should have gotten the easier palms, easier, and this is going to pay me. No. Every friend's path. Yeah, it could be a lot of friends. Okay. So the friend has to be in one of these, right? Problem is if it goes back and forth, then it may be a little bit weird. Right? Because that's the hard part, is the going back and forth, I think. If not, then this is actually pretty easy. Well, I don't know about pretty easy, but easier. How do I handle that case? Where does this thing go? How do I abuse this? People are starting to get it. Guess it should be in order. Oh no. Again, the issue is duplicate numbers, but such a sort of prefer search. Okay. So now. What is N again? Oh, number of cities. M is the number of flights. Okay. Okay. I guess technically I didn't need to do this. I can just do. I don't know if this is going to be fast enough. How many people have gotten this so far? Oh, okay, so a bunch of people. Wow, a lot of wrong answers too, though. So the key is to start. Okay. It's gonna be a mess. It's just so slow. I don't know what I'm doing. That's odd. Oh, that's because I'm dumb. Okay, this is a start. So 2, 3, and 4. Okay. Oh, because I break afterwards. That was just for testing, but it's still not working. 2, 3, and 4. You processed the 2. We really should get it in here. The 2 doesn't do anything, so this is doing nothing. Okay, so I didn't process this correctly. Okay, so there's some stuff here. Okay, this is just... Oh, because X is not a tuple. Okay, so it's doing something, just nothing productive yet. That's fine. Okay, this is good. Maybe. It's missing something though. Five. Oh, oops. I have a +1 here, even though it... Okay. Okay, so this is probably right, but is it going to be too slow? That's the question, I guess. Still 45 minutes. Let's slow it down. I've been really sloppy today. Let's do a test case. That probably is not the answer though. Why is this 2 for this one? Oh, because I think I put it wrong. Okay. It shouldn't be 2 though. Shouldn't the answer be 3? Maybe I got it wrong though. Wait, also isn't this... No, this answer is not 3, but... No, this answer should be 3, so I'm getting something wrong. So let's just for... I'll get it submitted, I guess, because this is clearly wrong. So let's debug this. This one is 2, 2, 3. We only have 6. 2 and 6. What? 2, 2, 3. The next one is 4. But I'm getting some weird things. Why is that? Dun, dun, dun. Oh, this is silly. I copied and pasted this from before, but this should be just P of K. No, So K is, whatever is it? Oh, this is just P of K. Good thing I tested this. Okay, so this is good. Wish I kept my thing about, okay. I guess 10 is right, it's fine. Okay. Is this fast enough? Might not be fast enough, to be honest. Oh, wow. I mean, that was fast enough, but really slow. Well, that is a lot of things, though. That's 10. So that... This test case is actually way bigger than the input because of the sum of this thing, but is that right though? 11? It probably is right. I think there was 11 elements. I counted. Okay. Okay, let's just give it a go. Hopefully it's fast enough. It might not be, and that's fine, because I'll get a test case for me to kind of... Yeah, it's too slow apparently. Hopefully they give me the test case. Oh man, they give... I don't even get a free test case for 5 minutes. That's kind of sad. The sad thing is, I think this is fast enough for one test case, but not because we did some of these, right? So times say 10. Like this is a upper bound for this, and this should be fast enough. Oh, maybe not actually. Because of the duplicates. This one's hard. Even memory limited exceeded. Okay, well, so maybe that isn't even in the test case. How would I do this case? This is probably one of the worst cases, though. In theory, maybe I just do this instead. Again, the overlapping one is the issue that I don't know how to do. Maybe I've gotten this. Poop. Okay, well, I'll remove this before I forget it. The tuples are weird. Can I save this in a more efficient way? So to start, So I don't even need this. I just need how is it even current? We don't even need the current. Oh, this isn't. This is P of K. Did I do it wrong? Maybe I did it wrong. Oh, well. Okay, I mean it's still wrong, but at least it starts. And at least it time limits exceeded instead of memory exceeded, but it's still bad. Huh. How do you do? They're all ones. Why is this wrong? Oh, whoops. I knew that. Pay to win. Okay, so this is right. But this is still going to give me the wrong answer, or time limit exceeded. I don't know what to do. $50 people got on it. But this one is the case where it goes back and forth. I don't know if I can optimize my current thing. That's okay. Alright, let's do a smaller case so I could print it. The smallest case is fast. Yeah, that's what I feel. There's way too many elements in this. How do I process this in a smarter way? because now this becomes n square. I don't know. This would be a good contest to have a good first Q3, I guess. But I mean, that'd be funny if you just needed to do suffix tree or something. Maybe, yeah. Suffix tree would solve this, but I don't really have an implementation out. And if it is, and if suffix tree is the implementation, then that's just that's just not going to be it. Well, like I'm fine with not getting it. This is going to be n square. I don't know how to do it. At least not without some weird suffix tree stuff to get it down to constant time. I don't really have a suffix tree implementation though. Maybe this is just a bad streak for me. I think can we skip any of these? Just in a different order a bit. Basically, if so, how long can this possibly be? Well, does this give me the right answer first of all? It does. Why does this not make it faster then? Okay, so this should be faster, but why is it not that much faster? Or at least enough for me to go. Okay, well, to be honest, there might be even more, but that's unfortunate. Even 10 of these is too slow. That's a little bit sad, actually. Okay, well, maybe it's not too slow, but it's a little bit. I mean, it is too slow, even with the pruning. I just don't have an idea on this one. I don't know, now I'm just pressing random buttons, but okay. Yeah, I don't know how to do this one. Can we binary search on the answer? Don't think so. Yeah, I mean, you can binary search on the answer, but I don't know if it's going to be fast enough. Let's do it. No, because I feel like if that's the case, then people would have gotten it much easier, but I don't know. Yeah, let's try. Better than nothing. I just googled it in case you're wondering. Don't even have enough time to do it, but oh well. Oh, it should be okay. It should be good. Do I have time to test this? This is going to be fast enough. It's roughly fast enough. It's faster. But that's a silly problem if this is the case. Off by one, maybe? Oh. Why'd I have the wrong answer? If this is good. Now this actually. I only have more time to debug this. Why am I off by 1? This is basically all of them except for the last number. Is it just like another? No, I still have it wrong, so it's not that. No, so okay, so it's not that, at least not for now. Why is this wrong? Did I just not do this correctly? Maybe I just didn't do it correctly. 32 is false. Why is 32 false? This debugging sucks in the last moment. Wait. So why not? Did I mess this up? How can this be wrong? Why? How are you wrong? How do you forbid me now? Off by 1 on sliding window. Okay. I actually thought about that while I was doing it, but I was just being dumb and forgot. We have 3 minutes to go. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this forum. It was a tough contest, so hope you did well. Yeah, stay good, stay healthy, to good mental health, and I will see you later. Bye-bye.